We're still in video 2. I just broke it up into 2 videos because I didn't want one really long one. We're on page 14 and we're starting section 1.4. We're going to talk about when you have a linear equation that is not in slope-intercept form, but instead it is requested that it's in general form. General form looks like this. You have your x term combined with your y term, and it's equal to a constant. The only thing is a, b, and c are integers, so that's all the whole numbers and the negative numbers, but a cannot be negative, so that's it. A cannot be negative. It really has to be some kind of number that starts at 1 and goes forever. So what I'm going to do is I'm going to go over some examples real quick to change some of these from slope-intercept form to general form. For a, y equals negative 3x plus 4. I'm just going to add 3x to both sides. So now I can write this as 3x plus y equals 4. And this is in general form. I have my x term. The coefficient is positive. I have the y term equal to the constant. General form. It's really not that bad. For b, this is almost in general form, except I have to have the x term in front and the y term in the rear. So I'm just going to rewrite this as 5x combined with negative 2y equals 6. It really just changed the order of the two terms in the front, making sure that the correct symbols were still in front of them. Let's look at C. We have a couple different things here that are issues. The first, well, actually just one thing that's an issue. This is not an integer. Integer is a whole number. So what I'm going to have to do is I'm going to have to change how this looks to make it so we don't have any fractions. Now, anytime you want to get rid of a fraction in an equation, the best way to do it is to multiply each piece by a common denominator. Now, this is really easy to find the common denominator because the second two pieces are over 1. So the common denominator here is going to be 3. So I'm going to multiply the first term by 3, the second term by 3, and the constant by 3, because I can do this as long as I do it to every piece. That allows me to cross cancel the 3's and write that first term as 2x minus 12y equals 3. Now this is in proper general form. Of course, I'm going to give you something ugly. Look at that. Okay, so fractions. We have 5, 1, and 10. My common denominator is going to be 10. It's the smallest number that 5 can go into, and 10 can go into, and 1 can go into beautifully. So I'm going to multiply each piece by 10. This will allow me to cross cancel. 5 goes into itself once, goes into 10 twice. 10's over here cancel. So now I have negative 8x equals negative 50 plus 3y. Couple things that we have to do here. We need to probably go ahead and take 3y away from both sides. So we have negative 8x minus 3y equals negative 50. This is almost in proper general form, except we don't want this to be negative. So what I'm going to have to do is I'm going to have to multiply both sides by negative 1. Because I can do whatever I want as long as I can do it to both sides to manipulate this so that it takes on the proper appearance. So I'm going to multiply this side by negative 1 and this side by negative 1. When I distribute my negative 1, I get 8x plus 3y. On this side, negative times negative 50 is positive 50. There is proper general form. All my terms have integers in front of them. In the very first term, it's a positive integer. Page 15, find the x and y intercepts of a line algebraically. Now, there's a really simple strategy to this. We are not visually looking at these lines. We're going to do it algebraically. And it's very simple. So to find the x-intercept, we are going to plug in 0 for y and solve. To find the y-intercept, you're going to plug 0 in for x and solve. I know it sounds crazy. It's really not that bad. So what I usually do is I kind of set myself up with two different areas. One of the areas is going to be for the x-intercept, and one of the areas is for me finding the y-intercept. Notice that for the x-intercept, I have to plug in 0 for y. Down here, I'm expecting to have an ordered pair as my end result. If I'm plugging in 0 for y, then I need to plug 0 in for y on my coordinate pair. And then I'm going to plug 0 in for y in the, oops, I keep messing up here. Let's go back. There we go, in the linear equation. So here's my linear equation. Here is 0 plugged in for y. I'm going to go ahead and subtract 4 from both sides. So now I have -4 equals -3x. And then I'm going to divide both sides by -3. That will give me an x value of 4 over 3, because a negative over a negative is positive. 4 over 3 goes in that spot. There's the x-intercept. For the y-intercept, we're plugging in 0 for x, so my ordered pair is going to have 0 in the x box. X spot. I've been around my teenager too long. X box. I plug in 0 for x. It's going to cancel out my first term. Y is 4. This is no surprise because we've already learned in some of the past lessons that this is the y-intercept if you have your equation in slope-intercept form, which you don't always have it in slope-intercept form, so it's kind of like not always something you can rely on. For instance, B is not quite in general form, but it doesn't matter because it's just a linear equation that we're trying to find the x and the y-intercept for. So x-intercept here, y-intercept here. For the x-intercept, I plug in 0 for the y. So -2 times 0 plus 5x equals 6. 5x equals 6. X is going to be 6 over 5. It's ugly, but it's okay. It's allowed. For the y-intercept, I'm plugging in 0 for x. So I'm going to go ahead and plug in 0 into my coordinate pair. That's going to be my answer. And then I'm also going to plug in 0 where there's x. -2y equals 6. Y is -3. There is the x-intercept. There's the y-intercept. There is methods where you are using the intercepts to plot points and draw a line, and this is enough information. All you need is 2 points to draw an accurate line. So this is one of the methods for plotting and drawing a line from a given linear equation. Okay, so find and label the x and y intercepts for the following graph lines. If they do not exist, write D and E. Notice that these lines are two of the special cases. One of them has undefined slope, and the other one has a 0 slope. So it's not positive, it's not negative. Notice the undefined slope goes through 1, 2, 3, 4 on the x-axis. So it does have an x-intercept, which is 4, 0. But it never hits the y-axis, so there is no y-intercept, D and E. The second example, it goes through 4 on the y-axis. So it has a y-intercept, which is 0, -4. I didn't say -4, but I meant to say -4. It has no x-intercept because this never touches the x-axis, so that gets a D and E. Alternatively, you should also be able to write an equation for lines that are 0 slope or undefined slope. It's pretty simple, although a lot of people usually get confused unless they listen to this one piece of advice. Look for the axis that the line pierces, like a arrow. In this case, this arrow pierces the x-axis. So this should start with x equals. It pierces the x-axis, 1, 2, at 4. So my equation is just x equals 4, which makes sense because every point on this line has an x value of 4. 4, 2, 4, 4, 4, 9, 4, 100. Yeah. This one pierces the y-axis, so it starts with y equals. It pierces the y-axis at -4. That is the equation for that line. Not your traditional equations. These are kind of some special cases, and they're strangely easy as long as you brush up on it and keep it at the forefront of your mind. Graph the following linear equations. Y equals -1. This is where y equals -1 on my y-axis. So if it starts with a y equals and it's just a constant number, that means it's going to be a 0 slope that pierces the y-axis at -1. This pierces the x-axis at +2. Not terrible. Something. Not terrible, though. Okay, so if you're going to be writing equations for lines, every time you're tasked with writing the equation for a graphed line, you should always set yourself up to write it in slope-intercept form, where you are looking for numbers that you are plugging in for m and b. So you're always looking for the y-intercept and the slope. So I'm going to start with this first one. Y equals, I'm going to, there, I know the m goes here and the b goes here. B, really easy. There it is right there. It's +1. I'm going to find 2 points perfectly on the grid lines and do my rise and my run. Rise 1, run 2. Found my graphed equation. I found my equation for my graphed line. Try number 2. Again, y equals blank x plus blank, and remember that the slope gets paired with the x. My y-intercept here is +3. My slope, let's rise 3, run 2 units in the negative direction, so it's 3 over -2, and yes, you can leave your fractions improper and ugly, and it's okay. Take a moment. I want you to do 3 through 6 and then come back and check your answers with me. So you're going to pause the video and do these examples and then unpause to get the answers. Okay, so for number 3, my slope is rise 1, 2, 3, 4, run -3, so 4 over -3x, and then 1, 2, 3, 4 is my y-intercept. For number 4, my slope is rise 3, run 4, rise 3, run 4, and then my y-intercept is -1. For number 5, you have a 0 slope. It pierces the y-axis at, oh goodness gracious, I must have done something really bad with this, but this is where the axis is supposed to be. The origin, well, yeah, this is the x-axis. It's not here. Oi. Okay, starting there. 2 units up, y equals 2. God. And then for number 6, this pierces the x-axis at 1, 2, 3, 4 units. So x equals 4 is number 6. We're on page 18. Starting off on page 18, so now we're on section 1.5. We are going to use what we call the point slope formula. It's a little bit different from slope intercept form. I feel like we're getting to the point where you're hearing the phrase point and slope and so much that it's all blending together. Basically what you need when you are looking for a linear equation algebraically and all you have are just 2 points is this super awesome formula. because all you need to do is you need to plug in a number for slope, and then you're going to need to plug in one ordered pair, which is funny because usually you're given two ordered pairs, so you get to pick which one you get to use, which is really cool, because you have a little bit of control here, right? So let's try this with the first example on here. Find the equation of a line that goes through points 2, 5, and 1, -3. Remember, anytime you use the point slope formula, you need not just one point, but you need a slope. And to find the slope, we're going to use that trusty delta y over delta x. Remember that if I choose this to be my x1, y1, then the other one is going to be my x2, y2, and it doesn't matter if you chose differently as long as you're consistent. So let's do this. My y1 is 5. My y2 is -3. My x1 is 2, and my x2 is 1. 5 combined with 5, -3 is 5 plus 3, two negatives next to each other with nothing in between. Your slope is 8 over 1. My slope is 8, so I have a slope right there. I'm going to pick this. It doesn't matter which one, but I'm going to pick this first ordered pair to plug into my formula. The formula for slope-intercept form as written above is this. I'm plugging in 8 for the m, and I'm going to plug in 2 and 5 for x1 and y1. So here we go. Y minus 5 equals 8 times x minus 2. Remember that that 5 and that 2 came from here, and they are only next to negative symbols because that's built into the formula. I'm going to distribute my 8x minus 16, and then I'm going to add 5 to both sides. So I have y equals 8x minus 11. It's kind of like a really tidy, straight to the point kind of ordered pair, or not ordered pairs, for formula to get you where you want to go. There are other ways to do this that take more steps, so I'm trying to give you the best one. Go ahead and take a moment, do the same steps, do the second one, pause the video, do this example, and then come back and see if we got the same answers. Okay, that first step is going to be to find the slope. You're going to use delta y over delta x. I'm going to use this as my the first ordered pair. So 4 goes in the y spot, and -1 goes in the x spot. This is going to be my second one. -4 is in the y spot, -2 is in the x spot. 4 plus 4 is 8. -1 plus 2 is +1, so my slope is going to be 8. Then I am going to use the point slope formula. Now that we know that 8 is the slope, I'm going to plug that in here. I'll use my very first ordered pair. So I'm going to have y minus 4 equals 8 times x minus -1. I'm going to be distributing my 8. So I have y minus 4 equals 8x plus 8. Add 4 to both sides. My end result is going to be y equals 8x plus 12. Page 19. This may be review, may not, I don't know. Parallel lines. I'm going to draw a picture of an example of parallel lines. There's not scientifically the best drawing, but parallel lines never intersect. Lines that are parallel have the same slope. So this time I'm referencing the number that describes the slope of the line. Perpendicular lines look like this. Perpendicular lines intersect to create 90-degree angles, or right angles. Lines that are perpendicular have slopes that are negative reciprocals. For instance, if I have a line that has a slope of 2/3, the line that is parallel is going to have a slope that is the opposite symbol, so it's going to be negative, and you have to flip the fraction 3/2. These two lines would be perpendicular lines. If you have a line that has a slope of -3, its perpendicular line will have a slope of positive 1/3. Switch the symbol, flip the fraction. Here are some questions real quick asking you if the lines are parallel, perpendicular, or neither. Every time you're only going to look at the slope and evaluate it knowing what the slope is. For the first one, these slopes are not the same number and they are not negative reciprocals, so this must be neither. For number 2, these are not the same number. They are negative reciprocals, so we will say these are perpendicular. Number 3, we can't really evaluate this until we distribute the 3. When you do, that's y equals 6x plus 6. Notice that the slope is the same. That would mean these are parallel lines. On page 20, just a few different examples of finding an equation of a line. Now at this point you're starting to get clues about certain parts of the line. For instance, this clue is about the slope, and you have another little bit of information here. After using the clue for the slope and the point, you should have enough information to be able to use the point slope formula. If you have a parallel line and it's parallel to this line, that tells you that the slope must be the same. Notice you have more information here than you need. Don't let this throw you off. It doesn't say anything about the y-intercept. You're just evaluating that for its slope. And so now I know what I'm plugging in for m. It's -2. I'm plugging in 1 for y1 and 1 for x1. So if I distribute my -2 and then add 1 to both sides, here's the equation of a line that's parallel to the line y equals -2x plus 3 and goes through points 1, 1. Looking at another example that you might see, you again have some kind of clue about what the slope is going to be. Perpendicular means it's going to be the negative reciprocal. So I'm looking at this equation right here. The negative reciprocal of -1/2 is positive 2/1. So the slope of this line that I'm looking for must be 2. I'm going to prepare my point slope formula. I'm plugging in 2 for m, and I'm plugging in -2 for x1 and 1 for y1. So y minus 1 equals 2 times x minus -2. Two negatives next to each other with nothing in between become a positive. Distribute the 2 and then add 1 to both sides. So y equals 2x plus 5.